day, ma'am. Today I'm going to discuss three topics. First is about atom and elements. Second is about rocks. And third is about solar nebula theory. So let me start with atom. So what is an atom? Atom is a chemical unit that cannot be broken down by chemical means. It is composed of protons, neutrons, and electrons. Protons and neutrons form the nucleus of an atom. Nucleus represent tiny fraction of the volume at the center of an atom, but nearly all of the mass. So electrons orbit the nucleus is discrete shells or energy levels. So shells represent nearly all of the volume of an atom, but only a tiny fraction of the mass. So numbers of electrons and protons are equal in a neutral atom. Ordinary chemical reactions involve only outermost shell electrons. On the other hand, an element is a substance that cannot be broken down into others by ordinary chemical reactions. So chemical bonding is controlled by outermost shell electrons. So elements will typically be reactive unless their valence shell is full. So atoms or group of atoms with unequal numbers of protons and electrons, thus having a non-zero charge, are called ions. Positively charged ions are known as cations, and negative charge is as anions. So positive and negative ions are attracted to one another and may stick or chemical bond together. So there are three kinds of chemical bonding. So first is ionic bonding. So it involves transfer of valence electrons from one atom to another. And next is covalent bonding. It involves sharing of valence electrons among adjacent atoms. And lastly, the metallic bonding. Electrons flow freely throughout metals, result in high electrical conductivity. Atoms of an element with different numbers of neutrons are called isotopes. Isotopes may be either stable or unstable. So, stable isotopes retain all of their protons and neutrons through time. Unstable or radioactive isotopes spontaneously lose subatomic particles from their nuclei over time. So stable isotopes can be used to track climate change over time. So now let's move on to the second topic, which is rocks. So there are two beliefs as to how do rocks form. Neptunists believe that all rocks, including igneous rocks, were formed by deposition from early global ocean. The ocean receded and the Earth's surface has been much the same ever since. While Plutonists believe that rocks formed by igneous processes, for example, all rocks formed by crystallization from magma. Neither correct but sparked a healthy debate. So, rocks are any solid mass of mineral or mineral-like matter occurring naturally as a part of our planet. There are many types of rocks. First is igneous rock. It is formed by crystallization of molten magma. Next, sedimentary rock is formed from the weathered products of pre-existing rocks that have been transported, deposited, compacted, and cemented. Next, metamorphic rock is formed by alteration of pre-existing rock deep within Earth, but still in the solid state, by heat, pressure, or chemically active fluids. Next, magma is molten material that forms deep beneath the Earth's surface. And lava is magma that reaches the surface. Next, weathering is a process in which rocks are broken down by water, air, and living things. Sediment is weathered pieces of earth elements. So, intrusive igneous rocks are formed when magma hardens beneath Earth's surface. So, extrusive igneous rocks are formed when lava hardens. So, let me move on to the last topic, which is the solar nebula theory. This theory states that gaseous cloud from which in the so-called nebular hypothesis of the origin of the solar system, the sun and planets formed by condensation. Swedish philosopher Emanuel Swedenborg in 1734 proposed that the planets formed out of a nebular crust that had surrounded the sun and then broken apart. So proposed by Immanuel Kant 1755 and Pierre-Simon Laplace 1796. According to this theory, the sun and all the planets of our solar system began as a giant cloud of molecular gas and dust. Then, about 4.57 billion years ago, something happened that caused the cloud collapse. This could have been the result of a passing star or shock waves from a supernova. But the end result was a gravitational collapse at the center of the cloud. So from this collapse, packets and dust and gas began to collect into denser regions. As the denser regions pulled in more and more matter, conservation of momentum caused it to begin rotating, while increasing pressure caused it to heat up. Most of the material ended up in a ball at the center, while the rest of the matter flattened out into disks and circled around it. While the ball at the center formed the sun, the rest of the material would form into the protoplanetary disk. So the planets formed by accretion from this disk, in which dust and gas gravitated together and coalesced to form ever large bodies. Due to their higher boiling points, only metals and silicates could exist in solid form closer to the sun. And this would eventually form the terrestrial planets of Mercury, Venus, Earth, and Mars. Because metallic elements only comprised a very small fraction of the solar nebula, the terrestrial planets could not grow very large. In contrast, the giant planets Jupiter, Saturn, Uranus, and Neptune form beyond the point between the orbits of Mars and Jupiter, where material is so cool enough for volatile icy compounds to remain solid. Example, the frost line. The ices that formed these planets were more plentiful than the metals and silicates that form the terrestrial inner planets, allowing them to grow massive enough to capture large atmospheres of hydrogen and helium. Leftover debris that never became planets congregated in regions such as the asteroid belt, Kuiper belt, and Oort cloud. So that's all, ma'am. Thank you.